All right, let us begin. Those that are joining late may always be able to collect the recording at the end, so I'm going to get going. A warm welcome to everyone. We are so grateful and thank you for all your time and attention today. We are so grateful for this amazing technology to be able to connect with you all. If we were all assembled in a school hall somewhere, that school hall would be packed. And wow, that hall would be filled with a lot of smart people. In a moment, I'll introduce you all to the team. But for now, a quick intro about me. I'm the CEO of the Answer Series. It has been an honor to be entrusted by my parents and founders, Anne and Dave Eadie, to run the business these last 18 months. And wow, what a lively 18 months it has been. Now, today marks a momentous day at the Answer Series, and we affectionately call it TAS, the acronym for the Answer Series. Some people call it TAS, and we quickly remind them, you got to put a bit of jazz in the TAS and call it TAS. We've been laser focused at what we call completing the stable. In other words, having a book in every subject in high school in South Africa. And we've been really focused at completing the stable since the curriculum change to CAPS in 2014. And making sure that you all, teachers and learners, have the most up-to-date material for completing your thankless jobs. With the stable near completion, we can now start turning an increasing portion of our attention towards supporting South Africa's teachers in an endeavor to really join arms in attempting to raise the standard of education in South Africa. At TAS, we frequently speak and live our purpose, which is to impart the gift of confidence. Confidence being the key word. Our primary audience, of course, over the years has always been the learner. But this means we have a deeply held common interest with all of you here today. I'm sure my mother, Anne, won't mind if I share a quick story about her to illustrate the roots of this purpose. Some of you may not have guessed it, but my mom, when she was a very young maths teacher, was not confident. In fact, she might even say she was mildly terrified. And this was a core emotional reality for her at that time. And it's this emotion that was at the heart of her creative inspiration for the whole effort of the Answer Series, now 45 years on, to provide materials that would allow learners and teachers to feel confident that they could overcome their fears and master their subjects. So we wake up to impart the gift of confidence each day at TAS, and we hope today is one more step on the level 3 and 4 questions in mathematics and the confidence that you as teachers can grow, and ultimately your learners that will benefit. In today's webinar, Anne is joined by two metaphorically tall trees in the field of mathematical education who will field the majority of the questions following Anne's section. Susan Carletti is the head of advanced program maths at Rondebosch Boys High, and Jenny Campbell is the head of maths at Bishops. The format today will take 3 parts. We'll hear a presentation from Anne Eadie on level 3 and 4 questions, as promised. That will be followed by a Q&A section in which Jenny and Susan will respond to your questions. Which brings me to the Q&A procedure. So during Anne's address and her presentation, please take the time to write down any questions in the Q&A chat at the bottom of your screen. There's a Q&A section at the bottom of your screen. Pop them in there, and that will allow Gretel Lamper, who's going to be facilitating the Q&A section, to aggregate your questions, direct them at Jenny and Susan, and make sure that that section is a power section and really elevating the most valuable things for you. The third section of today is we have quite an exciting announcement for all of you. So stay tuned to the end. We look forward to this incredible journey. I now hand over directly to you, Mom. Enjoy it.
Good afternoon, everybody, and welcome. Yeah, such an incredible experience, I must say, an opportunity to get together to discuss this very exciting issue of level 3 and 4 questions. I just want to say at the outset that all the course material, all the slides, in fact, more than just the slides, there will be extra resources added, will be available on our website under webinar resources. So please just sit back and listen. And don't worry if I flip past all sorts of things, because as usual, I always try and squeeze too much in. I think this is almost, rather than a webinar, which is more likely a discussion, this is a bit of a package, which I'm hoping that you would be able to take away with you and start to just investigate and try out some things with your kids and for your own teaching. So let's get going. Our free ebooks are available to all teachers in the country and have been so since January. And then since COVID, we decided to compile grade 12 videos for free for all kids and teachers. And apparently they've been quite useful. And then we have a very nice motivational video, which you might like to listen to in your own time. So the research that I've done over the past 6 years has been extensive, but I'm just giving a few little snippets here today, because a lot of it is actually available for you to go and have a look at yourself in the diagnostic reports. But just in the last year, 11,824 fewer candidates wrote matric maths than in 2018. And there was a decline in performance, with only 35% of learners achieving 40% and above. Major problems indicated from that examination were the basic concepts and an over-reliance on past examination papers. I'd like to discuss these aspects in this presentation today. And this is what the diagnostic report looks like every year since 2014. This has been done where we have the percentage allocated for every single question, and then topics emerging as the difficult ones experienced by the children. And then even the per subsection, which actually shows even a wider range of topics that are problematic. There's often a discussion about level 3 and 4 questions, what defines them as such. Well, the proof of the pudding, as they say, this is how the kids have achieved in it. I'm not saying that this is a static situation. I'm hoping what might have been level 3 questions in the past could become very doable. And I do not see the challenge as insurmountable. Then also for paper 2, a similar thing in 2019, just putting forward there. And emerging are these topics. But what was really interesting was that I compared the results in 2019 with the average of the results over the previous 5 years, and saw in paper 1 a very disturbing and dramatic downturn in the performance of algebra, which is really serious because of the underpinning role that it has to play, not just in paper 1 throughout, but also in paper 2. And so just highlights the serious importance of having revision of algebra sort of built in automatically. I feel very strongly that focusing on basic concepts does not have to be a time-consuming thing, because I know time is tight. And when you're teaching matrics, you really can't imagine that you're going to teach the square of the binomial. But I really do believe it's worth it. And in these sections, say products and then factorization, the backwards and forwards, what I call reverse mathematics. This is one of the most basic examples of reverse mathematics, which is, you will see as we proceed, a continual problem for children. And then also the third level, that one really brings at home that basic algebra is the core of mathematics, and that one can also understand things backwards and not just memorize formulae. The laws of exponents, not just to know the laws, but to know why they are as they are. And then most importantly, again, this reverse mathematics seeing the laws backwards, which is not a natural thing to do. And so good to be studied. And when we have a look at exponents, which are 0 or negative or a fraction, I don't like to see these as laws. I like to see these as, let's examine the meaning of exponents like these. And then for paper 2, the big downturn was in trigonometry, massive drop to 34.6% average performance. We all know that the cognitive level questions occupy 45% of each exam. And for me, this is where the real maths lies. And that is actually what should be the fun part and why I feel that this problem is surmountable. I have in this grid and the following grid for paper 1 and for paper 2 indicated which the questions are for every year, for every topic that have been ones where learners have underperformed. And the idea of supplying this grid is to encourage you to, no matter which topic it is that you're busy with in paper 1 or paper 2, that you incorporate these questions as part of your teaching and assessing as a matter of habit. And so that all learners are exposed to this kind of thinking, which is really important. So about TAS, the answer series. In our grade 12 2-in-1, we have added a massive section on the challenging questions and memos for children to study, not to learn by heart, but to understand the ways of thinking. And that is what grade 12 Maths 2-in-1 offers, is a unique question and answer method of mastering maths, a way of thinking, developing conceptual understanding, you know, all the new framework demands, and focusing very much on the developing from basic concepts through to the more challenging, and including prior learning from grade 10 and 11. And it is with this in mind that one of the resources that we will be adding onto our presentation, which you will have access to, will be the DBE grade 10, 11, and 12 exemplar papers, which were brilliant papers. They were extremely comprehensive. And they had a wonderful thread for each topic, right through from grade 10 through 11 to 12. So my suggestion, and I followed by, I provided a sequence of concepts. So if one is about to do with grade 12s, APs and GPs, then maybe a week or two before, give them one question on a linear sequence, one on a quadratic, to just go and revise previous sections. Maybe average gradient in grade 11, you'll find in these papers as a precursor to learning about the derivative. And of course, the all-important compound angles in paper 2, where the trigonometry has to really be actually studied from the grade 10 and 11. And there's brilliant, brilliant work over there, especially the grade 11 trigonometry in the exemplar is superb revision, compact and very easy to offer as a tutorial. Quadrilaterals is here just to indicate that it's throughout. In grade 10, they talk about a kite, and then there's trapeziums and parallelograms, and the rhombus, what caught a lot of people out in the most recent grade 12 exam. Applying converse theorems, as I say, this reverse mathematics should be started in the most basic and foundational of theorems, with corresponding angles, alternate and co-interior, as being a means of proving parallel lines. And then incorporating the idea of using the midpoint theorem to do so, and subsequently the proportion theorem, so that one is not just walking straight into a grade 12 concept, but you've been getting used to reversing the mathematics all along. And then, of course, also applying those converse theorems in those examples there. So I try to distill what would be what has been asked for as an effective way of approaching level 3 and 4 questions. And I actually just had a multitude of words coming into my mind. But as I mentioned, Nana, a way of thinking is what we try to offer. By way of strategies, by way of visuals, we try to make sense of maths, to speak maths. Knowledge is extremely important, which is actually something that there's not enough awareness of. Knowledge of language, vocabulary, symbols, interpretation, theory, laws, procedures, theorems, formulae, concepts, especially integrated with one another, and then contexts. And the reason, therefore, for all the multitude of summaries that I'm going to be throwing in front of you, some of which you'll be able to look at and others we'll have to really zoom past, but which you will have to share with your learners freely. For me, the big word, though, was recognition. Using logic and seeing simplicity. And not recognition of questions because you've seen them 100 times before, but recognition of the actual mathematics, recognition of the logic, recognition of the simplicity. And ultimately, what our aim is towards self-directed learning as we impart the gift of confidence. So onto the questions. Paper 1, these lovely questions over here, I would like to propose that you give them to your grade 12s, the best class you like, and see how they do. And it's one of my first examples on what I call recognition. Are we recognizing, are our learners recognizing when they see 3 to the x, immediately knowing that that is always positive? And that immediately gives us the solution to this, because a plus times a minus is a minus, and therefore x minus 5 must be negative. Looking at an example like this, I remember being floored the first time I saw it. Oh, squares is what I recognize. Squares are always positive or 0. So if the sum of 2 squares has to be 0, the only way that can happen is if they're both 0, and so on, and we solve for x and y. You will see on the right that there are references to our grade 12 maths book, so that if you want to go and inspect the solutions any further, they are available for you, both as an ebook, and of course you are welcome to purchase it as a hard copy as well. We all know that learners can write down the answer to that in no time, but we lose an opportunity for logic here, because what happens if we replace that x by a y? Are they able to solve this equation? And if x is equal to 2, if x is equal to 2, then we know that that factor is 0, and and y can be any number. But if x is equal to any other number, then y has to be 3. And there's the logic. There is nobody that is born with that logic. It is logic that we can inculcate by using examples like this. My page has gone over. I just need to adjust my page. Okay. So then let's have a look at the third equation. I'm sorry about this line that is appearing at the top there. Just please try and ignore it. We'll have a look at the third equation. Normally, when asked for a third or given a third equation, we just ask to solve it. And learners get their guaranteed 5 or 6 marks. And if we're lucky, they'll remember to check the answers. Not that they would know why they would have to check them. I love the first part. It says, without solving this equation, show that the solution would lie in this particular interval, requiring the knowledge that 5 minus x has always got to be greater than or equal to 0, and that a positive third has got to be equal to something which is also got to be positive or equal to 0, and using those basic facts, which aren't very well known, to derive that. Then solving the equation, arriving at 2 answers, and then this lovely question, asking what would then be the solution to this one, which has got only this minor difference to the given one. And we realize that that was where the other answer applied, because when we square this, we get exactly the same procedure as when we square that. And now the whole third equation concept is complete. If we have a look at this, do our learners recognize a perfect square when they see one? And for which values of x will this be for positive? Well, we've just said a perfect square is always positive or 0. So now we have to exclude it being 0. And looking at that algebraically is very simple. X can be any real number, just not minus 4. But looking at it graphically is even more neat, where we can draw the graph very easily of f of x equal to x plus 4 squared. We see the x-intercept and the turning point of minus 4, and we can read off the answer there. When is this f positive? And of course, there is the same solution. The second question on that expression was, for which values of p will f of x equal to p have 2 unequal negative roots? And that one, I was not prepared to even try algebraically. It was just so incredibly clumsy. But if you look at our graph, which we drew a moment ago, for me, the problem in this question is that I don't think learners have an idea what the meaning is of that. That is an equation whose solutions are the points of intersection of the graph of f and of the graph y equals p, which is a straight line, a horizontal line with general form of the equation y equals p. And when will a line, which is a horizontal line, cut our graph of f such that we have 2 unequal negative roots? Well, when p is lying between 0 and 16, all those lines will suffice. So all lines y equal to p, which lie between y equal 0 and y equal to 16, is the answer to that question. The next one is even more amazing in that here you have 2 questions, each of which only count 2 marks. And the algebraic option to this is really horrendous. So if one looks at that, will your learners recognize that this is a positive parabola, a P1 if you'd like to call it, with a minimum, the turning point of 1, 5, and that g of x equal to 3 is a line, y equals 3, again, a horizontal line. Is it possible for them to be equal? Well, let's have a look. As soon as you draw the picture, the answer is very simply no. F and G have no points of intersection, therefore, that cannot be. And now you've done 2 marks worth of work. And in answering the next question, we get another similar one like this. This keeps coming up. This idea that gx plus k, y equal to gx plus k, is a straight line, again, parallel to the x-axis. And one can simply see that if we want there to be 2 unequal real roots, we have to push that line up more than 2 units. So the value of k must be more than 2. Or algebraic methods requiring more time, which, I mean, just look at them. I really would like to discourage that line of thinking as an only one. And so what we need to do is to increase the options, the strategies that learners have at their disposal, and to also have a look and see that the marks can give an indication of the effort they should be putting in. I received a special request from a teacher, Cheryl. Thank you for that, Cheryl. I have 2 graphs here, which I've put on the screen. And I love the question, the precursor here. The question was, find the equation of the tangent to f at x equals 2.5. And that in itself is a horizontal line. Obviously then, y equals minus 20.25. And again, this question, f of x equal to k, being used. And when, again, will there be 2 unequal positives, this time real roots? So any lines that lie between the one asked for and the line y equals minus 14, and therefore k would have values between minus 20.25 and minus 14. Quadratic sequences. We all are accustomed to this. Learners can, without any problem, deal with these questions every single time. Find the next term, find the general term, find the so manyth term. And what they learn from this is that moving from left to right, 3 plus 7 is 10, 10 plus 13 is 23, and also the bottom row. 7 plus 6 is 13, and so on. And they can move from left to right quite easily. But can they move from right to left? Because that should apply. Again, reverse mathematics. While I'm looking at this, I do need to point out that a lot of learners, in solving these common ones, these easy ones, will happily use 2a as a very nice, easy formula for the constant common difference, but won't know where it comes from. And I would like to really insist that if we are to get our learners to be confident in mathematics, they should not use a single formula which they cannot derive themselves. So I'm just putting in this little bit of theory here to make sure that you, test learners on this knowledge and make sure that they have that. And then, as opposed to this most unusual question, quadratic sequence, second and fourth terms, both equal to 0, second difference, 12, find the third term. So this is the situation. Second and fourth terms, both 0, find the third term. So let it be x. And how can we work this? We can work it by going backwards. What must we now subtract from 0 to give us x? Minus x. What must we subtract from x to give us 0? X. But it works in this line too. What do we subtract from minus x to give us x? We subtract minus 2x. There we go. There is our common difference, which we were told it was equal to 12, and therefore the value of x is minus 6, and the answer to the question. And that is a very, very elegant solution. My first attempt at this sum looked like this, which is not nearly as elegant. In fact, quite pedestrian, but there you go, another strategy. Symbols in mathematics, the language, sigma, sum of terms. Learners really struggle with this. As for seeing a sea of numbers like this, we need to invite them in. We need to tell them, take your time and just look. Oh, just 2 linear sequences, 1, 5, 9, 2, 6, 10. General terms we do know, and therefore the sigma notation. The sum of n terms. Please give this to your learners and see what they do with it. It's one of my favorites. And all it begs is for the learners to understand that symbols are the language of mathematics. graphs and functions, and occasionally calculus thrown in. But first of all, just looking at this vertical length over here, which is the difference between the y coordinates. 5 subtract -1 is equal to 6. We can see that a vertical length is the difference between the y coordinates. And that is really important in that concept, which is always a challenging one. But then determine the equation of the tangent to f, drawn parallel to g. So the equation of that tangent. And learners didn't recognize that this was calculus that was being asked. And that we have the gradient because it's parallel to that line. So we know the gradient of that tangent is 1. And we can use the derivative of the quadratic to find the point of contact and therefore the equation of the line. Over here, a little bit of analytical geometry is thrown in, but it's a similar case of, so we know the gradient of the line and we see that that is the tangent. Nowhere is the word calculus mentioned, but we are meant to recognize what we're seeing as the need for the derivative. Function language is really challenging for learners. And these are just some examples that I will give for you to do with your learners. Inverse functions. Inverse functions, 1 year was asked for a straight line, and I was absolutely amazed how devastated learners were and unable to deal with it nearly as well as they could with inverse functions for parabolas and exponentials. Maybe because the others were done a little bit by rote without needing to understand anything more than we just swap x and y and all is said and done. Here they really had to understand. The question was, if this is the graph of h, find the domain of the inverse function. And of course, the rest is all here for you to see. The range of h is that, and therefore the domain of the inverse is the same thing. And noticing and knowing and understanding that inverse functions are symmetrical to each other with respect to the line y equals x, and that points that are symmetrical to each other with respect to the line y equals x have swapped x and y coordinates. And that is why we swap x and y to find inverse functions. These first principle examples I would really like to encourage you to share with your learners, which were not asked in the traditional guaranteed 6 marks kind of way. They were asked in a way that expected learners to really understand where this definition of a derivative came from and about the average gradient versus the actual derivative formula. And I've highlighted what that would be important to share with your learners. And then what is calculus about? In grade 12, it is said it is just about the derivative, what it is, how do we find it, and where do we use it? And the optimization in calculus is one of the places where we use it, where we should immediately know that the derivative is 0 at the turning points because the gradient is horizontal. At the line, the tangent to the curve has a gradient of 0 at the turning points. And so one can always be guaranteed 70% by just taking that expression, getting the derivative, putting it equal to 0, and yeah, walking away from that. Am I just about to promote some rote learning? But you know, it does get learners started, and eventually they will understand what they're doing. And that advice is there. Again, some interpretation of graph language into English, which you can share. And we all are accustomed to that picture where we're given the derivative and we are asked about the original function. And over there, I offer this diagram, which makes it very easy to see the relationship between a graph, a function f, f dashed, and f double dashed. And that a positive cubic and a positive parabola and a line form that sequence, and we have that on the other side. I'm moving a little fast here because I'm running out of time, but consider the word mathematics in fundamental counting principle, and I suggest you give this example to your grade 8s first and see what they do with it. Because if you tell them that they've got to occupy these 5 slots and they can use those 5 letters as many times as they want, they will very quickly come and tell you those are the number of ways they could do it. And if they were not allowed to repeat letters, they would be able to give you that. But what our grade 12s have a problem with is remembering to apply the definition of probability. And when asked for a specific number of arrangements, that's all they give. Instead of, if asked for the probability, remembering that that number has to be over the total number, the very most basic definition of probability. Over here, we have a page which contains all the theory of probability, which makes it feel much more manageable and not such a vast subject. Paper 2, trigonometry, pre-trig essential revision, just a list here of absolute essentials, which is very brief and very important. Over here, the trigonometry summary. For me, what is really important with the summary, with the trigonometry, I'm not getting this thing to roll on me. I'm not getting it to increase. I want this to increase. Thank you. Okay, so in the summary, which you will be able to see much more clearly, you know, when you've got a bit of time, but the placing of an angle is extremely important. We know that often learners think that that little angle there is the, you know, is the angle talked about, but it is just the reference angle. For me, there are three barriers to trigonometry. One is the calculator. The other two are SOHCAHTOA and the CAST rule, because they, for me, are walls that stand between the learner and the understanding of true trigonometry. It doesn't take much to compare the definitions of sine and cosine to see they have the same denominator, and that because the sine of an angle is y over r, it will be positive where y is positive. And because the cos of an angle is x over r, it will be positive where x is positive. As opposed to tan, which has both y and x, and therefore positive in the first and third quadrants, the BMW symbol. These visuals for remembering the sine rates, the SIGNs, are very simple. And following from these definitions, also comparing sine and tan, which have y in the numerator, we know that they will be 0 on the x-axis, whereas cos, which has x as a numerator, will be 0 on the y-axis. And so we can know all our critical values very, very quickly and easily. And also from our definitions, understand why sine and cos can only have values between -1 and 1. And how easy it is to draw our graphs by point plotting. We can also derive our identities from these ratios. And then special angles. It's so important to know our families and to work with those families as a basis for understanding reduction formulae. This is a very interesting poster which you can share with your learners, comparing the actual angles themselves and the values of the sine, the cos, and the tan of those angles, and how the quadrants match and correspond. This is a very good example to share. I've highlighted all the critical issues to share with your learners. Area sine and cosine rules, for me the most important thing there is to end up ditching all the lettering and being able to learn what those formulae are in words and having the visual to accompany it, to see that the area and the cosine rule involve an included angle, whereas the sine rule does not. Again, this is the exemplar grade 11 trigonometry, by the way, which provides a great basis for revision for grade 12 trigonometry. The compound angles, distance formula. Learners fall down at the very first step at a very simple concept, which is simply difficult because it is unfamiliar. And that is to know what the coordinates are of a point a unit from the origin if I place an angle theta in standard position. X over 1 is the cos of theta, and y over 1, which is y, is the sine of theta. And therefore, if we place alpha and beta in standard position and look at a point p 1 unit away from the origin, the coordinates of p are cos alpha sine alpha, and of b cos beta sine beta. Then give your learners an assignment to find values, expressions for pq squared from both the distance formula and the cosine rule, and equate them and derive their own formula. This is a very intense slide, but if you think that this entire proof will have been actually originated by your own learners, then all they need to be able to do now is to derive those formulae, which the derivations are all there, as well as the derivations for the double angle formula. Another example here of application of the compound angle and the reverse mathematics, which learners find so difficult in applying the compound angle formulae. Seeing over here 4 sine 10 cos 10 as double 2 sine 10 cos 10 takes quite some recognizing and getting used to. But if we keep calling and referring to this reverse mathematics, it will be helpful. One of the main reasons for including this slide for you to share with your learners is the visitation of geometric series, converging geometric series here in the middle of trigonometry. A fantastic way of expanding deeper concepts. Strategy for 3D proofs. We only ever get 2 kinds of triangles. We only get 2 options in each. And if one presents that limit of the tools to sort out 3D examples, which learners usually run away from, then it somehow is more manageable. Euclidean geometry, some lovely summaries of quadrilaterals. The logic of this is that we keep refining the quadrilaterals all the way to the square, or we deviate from the parallelogram by a rhombus, or from a kite through to the rhombus to the square. The logic being that if a rhombus is a kite, it has all the characteristics of whatever precedes a particular quadrilateral. It possesses all the characteristics of the previous one. Vocabulary, very important to share with your learners, especially with this concept of septend and what is a cyclic quad really. Sometimes that is thought to be a cyclic quad. The grouping of theorems in circuit geometry is absolutely essential. There's so many, we need to group them so that they can be thought of systematically. If there is a center, if there is a cyclic quad, if there is a tangent. And then proving of theorems. That is where the logic in geometry is born, and where learners learn theorems the night before, memorizing them, and the entire logic is lost to them. And the logic that we apply in theorems is in fact the logic they will need in the application of the geometry. And so offering them visuals as the development and proof of theorems, where there's no lettering again, but they can just envisage. There's the construction each time, fill in the X's and Y's, and just logically go from one drawing to the next. And then challenge your learners to actually write the proofs out themselves. There are two very intense pages, which you will look at when you have time, where this is done for all the theorem statements in circuit geometry are on the right. What is the situation that they must learn to recognize in the examples? And then how do they derive these facts from that? So every single fact they use, they will have proved for themselves. And these are the examinable proofs. And so, yeah, very intense, but I think quite fun to have a look at as a new, refreshing way of getting learners to really enjoy doing proofs and it not being a sweat. Over here is just an indication of the gray arrows of how various theorems are used to prove others. The converse theorems, which I mentioned, were so important, and then a lovely worksheet over here, a tutorial, which is the 2018 geometry, just was packed with converse theorem questions and also visited by some trigonometry, again reminding us of the integrated topics. This is lovely. Proportion theorem only has one statement, and of course it's converse. So the challenge is simply always just to find the triangles in which to speak that statement or its converse. There are three triangles here, and clearly here the converse will be applied, and here the original theorem will be applied. And then some other examples to work through, and then eventually one that I really cannot not include, and that is this one, which is misleading because it looks as though it's the proportion theorem, but actually when one is asked to prove those, if you mark those lines on the triangles, you will see that it cannot be proportion theorem because the horizontal lines are being used. So it has to be similar triangles. So just marking the sides on your drawing helps you not only to decide what theorem to apply, but which triangles to apply them in. The analytical geometry toolkit basically is just an extremely useful, again, summary of saying to learners, these 2 pages contain everything you will need to know to answer any questions in analytical geometry. Thank you for bearing with me. I can now hand over. I'm sorry if I've gone a bit over time. Over to you, Gretel, my daughter. Thank you so much. And you and JD and Sue, good luck.
Hello, everybody, and thank you and well done, Mom. And thank you to those who have put questions in to the Q&A box. I'm sure there are many of you sitting with questions as well. So what we're going to do is have a look at the couple that have come through, and then possibly, even if there's time, if you do have a question that you're sitting with, please feel free to raise your hand. So I think let's take a look at Mom, I think this is a question that I'd love to start from you. There's a question about recommendations of teaching geometry in grades 10, 11, and 12. I know you're very passionate about this.
Recommendations?
for teaching of geometry?
Yes, yes. Well, I think it came quite clear in just my examples that I used in the circle geometry, you know, that logic must always be part of it. Discovery, as we know in geometry, is so essential, and vocabulary being one cannot proceed in geometry without getting the vocabulary sorted out, and that applies to all sections actually in grade 10, 11, and 12. And then, of course, the logic, and being able to introduce theorems and their converses right from early on, right from theorem of Pythagoras in grade 8.
Thank you. And just because geometry is such a topic that is tricky to really get our learners on to feel on top of and confident with, Jenny, I wonder if you have any gems on geometry that you would like to share with us. Is Jenny with us?
Can you hear me?
Yes, go for it, Jenny.
Right, so
thank you.
I think with geometry, it's particularly important that you do two things. Number one, encourage every child to have a few colors in their pencil box because they can't see anything when it all looks the same. So it is extremely helpful, particularly for weaker candidates, to highlight a circle, or if there are two circles, to put them in different colors, to highlight a cyclic quad in a different color. So color helps enormously. That's the first thing. And then the second thing is, I think they have to actually be a little bit crazy and ask themselves questions. So very often, if a child asks you, I will return the question and say, have you looked for a cyclic quad? What about vertically opposite angles? Maybe they're parallel lines. So I always encourage them to check what they've been given and to make absolutely certain that they've made use of every given fact at least once before they give up. So if they're parallel lines, what have they done with them? And if there are chords that are marked equal, in what way have they used that? So never ever give up until you've put everything into use. And then finally, the third thing is geometry questions tend to be very sequential. So if you're doing question 3 in a series of questions, you should, before you decide you're stuck, relook at what you did in the previous 2 questions to see if they are perhaps linked to the question that you have to do. So it's a lot about confidence. Even if you're a weak candidate, just talking yourself through the problem and not sitting there looking at it and not knowing where to start. Talk to yourself, ask questions, use color, and don't give up.
Wow, great. Thank you, Jenny. Hopefully that's a lot to inspire both teachers and learners. And interestingly, there's a question here on which computer programs could be helpful. Susan, I'm not sure if you have any knowledge or awareness here that can help to teach trig functions and geometry as well.
Hello, hi. With the geometry, I think it's very important to use computer animated programs, things like GeoGebra or Geometer Sketchpad, where the pupils can actually see things moving. And it makes a huge difference if you can do that. Desmos is also a very good one for graphs. So all your trig graphs would be great with that. And then they can see exactly what's happening with it. Just one other thing, if I can say, with the geometry, as Jenny says, use all the information they've been given, but go back, read what they were given and use it. The other thing I tell my boys is always to turn the diagram. So if they can't see what's happening, just turn the diagram on its side and see, can you see it from a different angle? And then if they still can't see it, rub all their scribbles out and start all over again. And so that's the advice I'd give with geometry.
Thank you so much, Susan. I see there are some hands up. So George, I wonder if you would like to unmute the first person to, or should we take 3 at a time, perhaps?
Sure, I'll manage the, so Zainab, I'm going to allow you to talk. We're all figuring this out for the first time, but I've asked to unmute, and Zainab, if you'd like to accept that, then you can go ahead and respond.
No, sorry, I think I may have clicked on the hand by
Okay.
accident.
Just keeping you on your toes there, no problem. We'll go to the next, Teboho. I've asked for you to be unmuted so that you can ask your question. I'm going to do the same for Vivo. And if they, okay, we in the interest of keeping everyone alert and attending here, I think there might have been some finger mistakes put aside there. I would kick back to you guys, Susan and Jenny, having heard.
Hello. Hello.
Teboho,
Yes.
go for it.
Yes. Thank you so much. I just want to offer an idea. I'm not sure what I will assist in terms of doing geometry at earlier grades, say grade 10. What I've realized working for me is an activity where you try to make learners to do construction. Say, for instance, you want them to be able to say, prove that the line from the center perpendicular to the chord actually divides. So if they can measure that and then realize that what happens, or the angle at the center is twice the angle at the circumference, they do the measurements of those things. They then begin to have the proof without necessarily doing the rigorous maths. That's what I've realized, that seem to assist learners to be able to grasp the concept and terminology of geometry. That's what I just wanted to sponsor as an idea. I'm not sure whether it is helpful. Thank you so much. Hello.
Okay. Thank you very much, Teboho. We'll take that as a conversation starter. Over to you, Gretel, Susan, and Jenny.
Yes, I don't know, Susan or Jenny, if you have any comments on what Teboho was saying.
Yeah, I totally agree with that approach. And what I find works very well with Susan's comment about GeoGebra, it's very easy software to use. And I have particularly weak grade 10 and 11 classes at the moment. And when I teach them the theorems and the concepts that Anne was showing so beautifully done in the book, if you give them a picture which is dynamic and you say to them, drag this picture around the circumference of the circle and tell me what changes. And they kind of quite stunned because it doesn't change, because anywhere in the same segment, the angles are equal. And then giving them a point where you can drag it off the circle so that it's not actually in the right place. And they can see that the relationship does change if you, so the more dynamic you make your sketches, it's easier. If they're working with pen and paper, which I have tried, I find the boys get very frustrated because they don't do their drawings accurately enough, or their compass wobbles, or the protractor's lost or left at home. But if they can do it, and with GeoGebra, you can work on a cell phone or any device. It's very dynamic and very easy to use. And you can create the sketches up front, and then they can take them and drag them around and do whatever they like to them. They can't really destroy them. And that visual understanding is absolutely everything. A picture speaks volumes as opposed to what you're trying to force into their heads. The setting with geometry, it's not what we've made up. It's actually what we've discovered. So geometry has always been there, but we discover properties that we can't make the angle at the center twice the angle of the circumference. It's simply something that we discovered. And the shortest distance between a point and a line. So I get the boys to the front of the class and I say to them, if you had to run from here to there and you wanted to win a chocolate, which direction would you run in and why? And they figure out very quickly it's the shortest distance. So that's why the radius is perpendicular to the tangent at the point of contact, because it's the shortest distance. So all the time that we're talking to them, we have to give them visual things that they can interpret and understand. And with that comes a lack of fear. They stop worrying about geometry and being fearful of it and start realizing that it's an amazingly interesting topic.
Thank you, Jenny. Susan or Anne, I see you've been unmuted, Ma. Would you like to say something?
No, I see two participants have raised hands. No?
Okay, thank you for that. George, would you like to unmute?
I'll unmute Geraldine, and hopefully she'll be able to respond. And then next I will unmute Faizan. So Geraldine, if you're ready to go, you can go ahead.
Not unmuted.
Okay, I've unmuted myself. Can you hear?
Great.
Hello,
Go, Geraldine.
Okay. Hi, everybody. I thought I would just perhaps just on a very simple level, I find what very often happens is they don't really read all the information correctly. So for me, just taking the time to read everything all the information that is given and mark it in on the sketch. I actually tell my boys, when you start a geometry problem, read everything, mark everything in, and read it again, because if you miss something, that could be vital in solving some sort of further, section further down. And then I tell them, don't look at what you have to prove. Mark everything in and take a few moments to analyze your sketch and look at things like, is there a center? Is there a center, a line from the center to the midpoint of a chord? Run through those things and just take a moment to actually get in your head an idea of the sketch. And it doesn't have to take long, but when you then start answering the question, your brain has actually had time to kind of almost, sort of picture a little bit more and kind of warm up to the sketch. And I find that so often when they just quickly read it, mark in something and go into the first question, they are locked into trying to prove that first part and they miss so much else. Whereas if they go in with a little bit of an open mind without having to focus in on what they're trying to prove and just spending a few moments analyzing, it kind of does sometimes help a little bit.
Great, Jenny. Please, Geraldine.
Thanks, Geraldine. Yes.
And then Faizan should be there.
Oh yeah, I'm here. Thank
Have
you
you got
very
a
much
question?
Yeah, actually, it's just a contribution, a comment.
Thank you.
What I've adopted over the years is that with my learners, before we start answering the questions, before they even look into the questions, once they have that diagram before them, I encourage them to identify as much theorems as possible, marking in all, if it's a numerical problem, marking in all the angles, applying the theorems, identifying as much theorems as possible, such they must make that diagram as dirty as possible before going on to answer the question, so that by the time they start answering the questions, they have basically almost all the answers before. That's what I can say at the moment. Thank you.
Mom, would you like to respond to Faizan?
Yes, I totally agree with him. I think it's really important to actually practice a lot. Just looking at drawings and seeing what you can all say about it without having the tension of the questions. But something one must actually guard against is that the diagnostic reports speak a lot about learners just writing down random facts. I think it's important to look at those facts, but then they do need to have a thread of logic once you start actually writing down your solution. So just that next step.
So I'm going to take back a little bit of the emceeing role here and offer Jenny and Susan, Jenny first, just a last chance to make a comment. And then we're going to move to the announcement. So Jenny, anything you'd like to say before we wrap up?
Yeah, the last thing I want to say is just an answer to a question. Actually, somebody asked about software for drawing geometry sketches. There's something called FX Draw, which I strongly recommend. It works absolutely brilliantly. It's dynamic. You can change your diagrams afterwards. We've worked with it for years and it works very, very well. So FX Draw. And then for the rest, I think the boys and the girls that we teach benefit enormously from our confidence in the classroom and our not being afraid, and just encouraging them to embrace difficult papers and to realize that when papers are difficult at the end of matric, they have a big advantage, because if they've worked hard, they will stand out in the crowd, as opposed to easy papers that hold no challenge. So our own mindset is fundamental to the way the kids prepare themselves for exams and cope in the end. Thanks.
Thank you. Brilliant. Susan.
Yeah, I think it's very important to develop confident learners. They need to be exposed to higher level questions from a very early age. So it's not enough to expose learners to these kind of questions in grade 12. From the time we get them at high school, and anyone who has them earlier, grade 7, I think it's critical that we teach and we examine with level 3 and 4 questions right from grade 8. And the pupils need to realize that they're going to get these kind of questions. They're going to need to think, and they need to be able to think in a class situation as well. And we need to develop pupils who are not scared to try questions. So when they see a question that looks difficult, it's not a case of just leave it out. It's a case of let's actually play with this and see what we can get. And I think regular exposure to questions like these is critical. It's like using the South African Maths Olympiad questions, where you take them, find a question that is relevant to the topic you're teaching and get it, use it with the children. And it might even be a case of you start every single day with a Maths Olympiad question so that you get the kids to start thinking. Thanks.
Brilliant, Susan, thank you. Last word from you, Mum.
Oh.
We're going to keep going, Gretz, because we're going to...
Yeah, I don't want to bring in another question, but just to say that I see the questions are really flowing now, which is wonderful. And some people missed some of the apps, etc. All these questions and information will be available with the recording afterwards.
Yes, excellent. Awesome.
So thank you. And thank you, Jenny and Susan.
Cool.
I like the last contribution there, just about maths being something that we think, not just do. And so that's for me really vital in our approach. So many children just think they just do maths, but it's actually the thinking that is to be focused on.
Amazing, amazing advice. And I think this just really brings us now into towards the end of our session here now, with an announcement, and that is that for next year, the Answer Series is going to be releasing a very exciting new forum, and it's an extension of what we've done here today to really share all our knowledge and grow together as mathematics teachers, and we're calling it Maths Majors. And in a nutshell, who is it for? Maths Majors is a community designed for mathematics teachers who utilize the Answer Series study guides in their classroom to make their lives easier, as well as to support their learners. What is it? Well, it is a learning community of mathematics teachers. The base camp of this community will be a private Facebook group, and this group will have conditional access. The only prerequisite for access is that after requesting to join, you'll be asked to send some evidence that you used TAS in your classroom. You can have fun with this. You can send a pic with your learners, or simply a document showing your order details. This condition is not designed to keep people out of the group because it's actually quite an informal prerequisite, but rather to send a clear signal about at least one powerful common interest that is the group, which is namely the common language of the Answer Series study guides. Further to the Facebook group, there will be a series of webinars next year building on these level 3 and 4 questions, as well as topics that are hottest in the discussions on the Facebook group. We'll look to add more value to this group over time, such as latest release content, and we're looking at ways that TAS can give back to schools out there for their loyal support over the years. Some of the items today that were highlighted, you know, GeoGebra, FX, FX Draw, or, you know, these are new apps that are helping teachers all the time. Let's pool our knowledge and make sure we're all using the best of the information available, and that best information gets spread very quickly amongst us. That's the idea. So why Maths Majors? Excellence is so often about who we surround ourselves with. We seek to attract ambitious maths teachers, eager to have a growth mindset and learn about teaching and learning together. And I think, Susan, you know, I think it was actually, sorry, Jenny, that really captured it, which was your confidence as a teacher is so instrumental to ultimately the confidence of the learner. So if in any way we can support you in your growth and your confidence as a teacher of mathematics, a demanding subject of note, we would feel greatly privileged to join you, and have you join us on this journey called Maths Majors. You will see there's a link there called, it's a Facebook group called TAS Maths Majors. Go on, click join, and make sure you don't miss out on the exciting aspects that are coming online for next year. So with all of that being said, a great a voice of appreciation to Mom, to you firstly, to Jenny and to Susan, and to all those that stuck up their hand and asked a question and put a comment in the group. We so appreciate your participation. I hope this presentation has been a resource to all of you. I'll wrap up now, but I'll open one more thing to anyone who's on the panelist group that'd like to say anything. Last thing. Going.
Just a big thank you to the entire TAS team for putting this together.
Absolutely. There are lots of
Hazel
people in
and
the
Bun.
background.
Great.
Absolutely.
Thank
Thank you to
you.
the TAS team. Good luck for the last push for the end of the year, everybody. We're really looking to help in any which way we can. So don't be shy to ask questions. We hope that we'll be able to help. Have a lovely evening. Good night.